we'll see the factor theorem now. If Px is a polynomial of degree n is greater than 1 equals to 1 and a is any real number, then what we have to see? X minus a is a factor of Px, that's what we have to prove. If Pa is given as 0, second, we have to prove Pa is equals to 0 if x minus a is a factor of Px given. Now we'll see the proof. So we have seen the remainder theorem in previous video, and with this, what Px is a polynomial such that x minus a qx plus Pa. Here remainder was there, which was Pa is equals to r. Pa. Now first case, x minus a is a factor of Px if Pa is equals to 0. Now what is given? That Pa is equals to 0. When I will replace this value with 0, what I will be left with? Px is equals to x minus a and qx. So this simply denotes that Px and qx are two polynomials where x minus a is a factor of Px. How? We can see with one example. Let's say I am writing 6 is equals to 2 into 3. Now this simply denotes that there is no remainder, or remainder is 0. So this 2 is factor of 6. The same way, this x minus a is a factor of Px, which we had to prove. Second case, what is given? If x minus a is a factor of Px, then we can see some other polynomial, let's say gx. When x minus a is a factor of Px, that means there won't be any remainder. It will be completely and exactly divisible by Px, by x minus a. Okay. Now we have to see that Pa is equals to 0 or not. Okay, we'll see. So we'll put the value of x as a. Pa here x minus a. I'll put the value a minus a, and it will be Ga. Now a minus a will be 0. It gives me Pa is equals to 0, which I had to prove. Alright, so that's what factor theorem is.